IP addressing prymatt. So this is one of a few lectures I've put together on IP addressing, subnetting, VLANs, CIDR. Really meaty subject, and it's the hardest area most novice engineers and IT students find. The hardest one to get your head around. There's lots of rules to learn, addressing methods, and then exceptions and how it's applied to the real world, and then how they're going to ask you questions. Really tough. But you know, this is why a lot of people don't pass the exams, because it's too hard, and this is why the money is pretty good when you pass CISCO exams compared to other IT qualifications, because you've had to learn more stuff than a lot of other engineers and vendors. So let's go into our primer anyway, and we'll just cover some of the basics. So all devices on the network need an address. Some time ago, 10-15 years ago, all devices on Microsoft networks could be given a name, and they were, I think, usually called net BIOS names. So each device would have a unique name, and that's how we communicated on the network. But pretty hard now with the size of enterprise networks we have nowadays. So the current version we're using, although companies are changing, and in the future it will be using IP version 6, but IP version 4 is an agreed common addressing standard for modern networks. And this whole thing has to sit upon the fact that all network devices or all networks can really only communicate still using electricity, and electricity can only be on or off. The pulse on the wire can only be on or off. So really all the addressing has to be built on top of the binary numbering system. Now IP version 4, it's getting fairly, well, it is out of date to be honest, but it's got workarounds to make it work still. But the current incarnation, it uses 32 bits, binary bits for an address, and each of those 32 bits is broken into 8 bits. So we've got 4 lots of 8 bits, or 4 octets, and each of those makes an address. And in binary it would look something like that, 4 groups of ones and zeros separated by a full stop, so we can make it easier to see. Speaking of making it easier to see, we see numbers in decimals, but it's important to remember that network devices can't understand the decimal numbering system. They only really work in binary. Now we can configure our devices so it actually displays numbers in binary, but why anyone would want to do that, I really don't know. The rules for network addressing is each address must be unique. It's pretty much like a house address. Each address must have its own street number and zip code, or if you're in the UK, a postcode. And now each address must have a subnet mask, and we'll cover subnetting in another lecture. Basic binary mathematics. Signals can only be on or off, so you can see here a signal on a wire, as I've represented with the lines, bars on the graph, 10, 11, 0, 0, 1. So these are the signals that are actually being read on the wire. Now we can create a very wide range of addresses using the decimal numbering system sitting on top of binary. So here's an octet, and we've got 8 characters within this octet. For binary mathematics, we start off on the right hand side with the number 1, and we just keep doubling it. So 1, 2, 4, 8, 16, 32, 64 and 128. So this is one octet. So each octet we could have a 0 under any of these values, or we could have a 1 or a combination. So I've put a 1 in some of these columns, the 128, the 16, the 4, 2 and 1. If you add those numbers together, it will give you 151. So you could have any number from 0, if you had 0 in all the columns, all the way up to 255 if you had a 1 in each of these columns. And there you go, there's an example of a 1 in each column added up. Alright, so addresses, this is historical, so don't worry about it too much. It's handy when we're doing our subnetting, but classes of address aren't really relevant anymore. It used to be that a big organisation would get a big range of addresses, a class A medium size, a class B, and everyone else would get a class C. Classes D is used for multicast traffic, and class E is experimental use only. Now, a Class A, the network will recognise that it's a Class A address because the first bit in the first of the 4 octets is always set to a 0. So that's how our network equipment can recognise the class of address. And this helps it then determine valid addresses and which is the correct subnet. Now, so if you add all the numbers together, bearing in mind you're not allowed to use the first column because there's a 0 in it, it actually gives you 127. You can't use the number 127 for a network address. That's used for loopback testing if you ping the address 127.0.0.1. So let's say if you have a 1 in the first column and everything else is 0, you've got the number 1, and if you have a 1 in all the other columns, that will get you up to 126 because you can't use 127. So these are the valid network numbers in the first octet for Class A addresses. For Class B, the first 2 bits have to be used on the first octet, and they have to be a 1 and a 0. After that, it doesn't really, the network doesn't care what are in the other columns there. So if you turn all the bits on, you will create the number 128. That's a 10 and then 1111111. That will give you 191. If you have 10 and then all the zeros, it will give you 128. So the possible range of addresses for a Class B network are 128 to 191. And again, this is a classic exam type question. Class C addresses, the first 3 bits have to be used now on the first octet, and they have to be 110. Now, if you have a 0 in all the other rows in columns, you'll have the number 192, which is basically 128 plus 64. And if you turn all the available bits on in the first column, then it will give you 223. And by all means, put these numbers in and work it out for yourself. So I've mentioned what the other classes are used for. Subnet masks, I'm going to come into this in a lot more detail later, but basically a subnet mask determines or tells the network what are the host bits and what are the network bits. Even if you're not doing VLSM, which is chopping your network down into smaller parts, you still now need a subnet mask. This is one of the preservation methods that was invented for IP version 4 because they were running out of addresses basically. So the subnet mask will tell the router or whichever device on the network which parts of the number are for the network and which parts are for the hosts. So we see here we've got an address 192.168.12.2 and the subnet mask is 255.255.255.0. So this tells the network which parts are for the network and which parts are for hosts on that network. So we can see our host on this network is .2, and that is on the 192.168.12 network. Any host with the first 3 numbers the same will be on the same network. So I've mentioned classes. Basically, Class A, only the first part of the first 3 octets. So the first of the 3 octets is for the network. And you can see you've got 3 whole octets available for hosts on that network. For Class B, we've got more networks but less hosts because we've only got 2 octets available for numbering for our hosts. And then Class C, we've got loads and loads of networks but only the last octet is available for hosts. So examples of addresses of Class A, 10 would be the network address, and then 243.11.1 is your host. And going down to Class C, 200.111.22 is your network, and .3 is your host on that network. Basic rules for subnetting and IP addressing: you can't use the network number. You can't alter that. So if you've been granted a number by your internet service provider, you can do whatever you want with the host part. You just can't alter the network part. So you can see here's just 3 examples for a Class A address. Oh, this is going further into it actually. For the rule for addressing is you can't use zeros for a host number. So for example, the 10 network, the 000, that isn't available, that address isn't available to be used as a network number. And we're going to come into this more in other presentations. I just want to bring this point up earlier. The next address down is a class B. The first two numbers are fixed. You can't use a 0.0 to allocate for a host number on your network. And for class C, you can't use a 0 on the last octet as a number for a host on your network. If this doesn't make sense at the moment, don't worry, because we're going to come into more detail later on. The other rule is, the first rule, you can't use the network number. The last rule is you can't use the broadcast number. And the broadcast number for a class A is all the 255s. The class B is 255.255 and class C is 255 in the last octet. Now we'll go into more detail with this when we're doing subnetting, but any broadcast number you can't use for a host number on your network. Okay, so that's the end of the introduction. Don't worry if this doesn't make sense at the moment. Come back to the presentation later. You can watch it as many times as you like, and post questions on the page here. And also things will start falling into place as you look at the other lectures as well.